Hi, today let's see how we can delete nodes from a linked list. Our first case is deleting the first node. Let's take this particular linked list, say 1, 2, 3, 7 and null. Here 1 is the first node and head is pointing to it. Deletion at the start means we want to remove the first node of the linked list, that is this particular node with the value 1. Because this is a singly linked list, we cannot move backward to delete a node. So instead of deleting the node, we simply move the head to the next node. So head earlier used to point to this. Now we move head to the second node. So once head stops pointing to the first node, that node becomes unreachable. So now this is the linked list, right? So now head is pointing to the second node. So when this particular node is unreachable, it is automatically removed from the list because it has no reference. And in a linked list, a node exists only if some pointer is pointing to it. Since there is no pointer here, it is automatically removed and we are left with this linked list 237 and null, and head is pointing to the first node now. So 2 is the first node here, 1 is removed. So let us look at the edge cases in this scenario. Suppose we have an empty list, say head and null. So if the list is empty, there is nothing to delete and we simply return the list as it is. And suppose we have only one node, deleting the first node makes it empty. So we have 5 as the first node and head is pointing to it. Suppose we delete this node, it becomes as head pointing to none. So this is an empty linked list. So in summary, deleting at the start requires us to move the head forward. It has no traversal and has a big of one time. Deletion at the beginning is the most simplest and the fastest operation in a single linked list. Let's quickly code this scenario. I defined a function delete at beginning and it receives head, which is a reference pointing to the first node of a linked list. Now let us quickly code how deletion at the beginning of a single linked list works. I defined a code delete at beginning and it receives head, which is a reference pointing to the first node of the linked list. The first thing we need to check is whether the list is empty or not. If head is none, it means there is no node to delete. So if head is none, in that case, we simply return none. If the list is not empty, deletion at the beginning is very simple. So we have head is equals to head dot next. We move the head pointer to the next node. This single step removes the first node from the list. In a single linked list, a node exists only if some pointer is pointing to it. Once the head moves forward, the old first node becomes unreachable, and that's why we don't explicitly delete the node. If the list has only one node, head dot next will be none. So after deletion, the list becomes empty automatically anyway. Since the head pointer changes now, we must return the head. So we simply return head. Cool. So let's quickly run this code against the test cases involving the edge cases as well. So as you can see, for an empty list, it just returns the empty list, and for a single node, it returns an empty list, and for multiple nodes, it deletes the first node as expected. And here we have 1, 2, 3, 7. So it deleted the first node, that is 1, and now the head is pointing to 2. So we are doing this entire thing without any traversals and it works in a constant time. So one simple takeaway from here is we don't delete the first node, we just move the head and the first node automatically gets removed from the list. Alright, let's now look at how we delete a node at a position x following one based indexing. So let's take this linked list, say 2, 3, 4, 5, 6 and null. And since we are following one based indexing, it starts from 1, 2, 3, 4, 5. So let's say we are given x equals to 4. Since x equals to 4, the node with value 5 is a node we want to delete. And we know for a fact that in a singly linked list we cannot directly delete a node. To delete a node we must first reach the previous node, that is this. So we initialize cur and we iterate till you go to the previous node. So now cur is at node 4 with index 3. Okay, so this is the x minus first node. Here cur is pointing to the node just before the one we need to delete. So now we need to change the next pointer of the previous node to skip the node we want to delete. Say we have 4, 5, 6 and null. Okay, so the next of 4 should be pointing to 6. Okay, this particular technique is called the leapfrog technique. Okay, so this is the leapfrog step that we did. So now we won't have any pointer pointing to 5 and this automatically gets deleted. So now our linked list will be 2, 3, 4, 6 and null. Now let's quickly go through all the edge cases. Suppose we have this linked list, say 2, 3, 4 and none, and head is pointing here. If x equals to 1, this becomes deletion at the beginning, which we already handled separately. And suppose we have 2, 3, 4, 6 and null. If the node to delete is the last node, we should make the previous node simply point to the none. It means, so the previous node of 6 will be this one. So this should point to none. So to summarize everything that we did right now, deletion at any position in a singly linked list always comes down to fixing one pointer. So just remember this one thing. You never delete a node directly. You delete it by changing the previous node's link. Now let's head to the coding part. Alright, let's look at the coding part now. I defined a function delete node here, which receives reference to the first node, that is head, and position of the node to delete following one based indexing. So as we already discussed previously, if the list is empty, there is nothing to delete. So if head is none, we can safely return none. Okay. For the second edge case of the deleting the first node, if x is equals to 1, we return head dot next. We already discussed this. So deletion at the beginning is handled separately by moving the head forward. Now we got to traverse to the previous node. So current is pointing to head in the beginning and count is initialized to 1. So we start a pointer current from the head and its only job is to reach x minus 1th node. Now we got to traverse the list until the current reaches the node just before the one that is to be deleted. How can we do that? We can do that using a while loop. So while current and count is less than x minus 1, current is current dot next and count is incremented by 1. And now before we delete, we should validate if current and current dot next. So what are we doing here? This ensures the previous node exists and the node that is to be deleted also exists. If not, the position is invalid and no deletion is performed. Now here comes the core deletion logic. Current dot next is current dot next dot next. Here we skip the node that is to be deleted by pointing the previous node to the next of the next node. So this single pointer change itself removes the node. Now we just return the updated head here, return head. Alright, so let's go ahead and run the code. So as we can see, for all the scenarios, we are able to delete the nodes at their respective asked positions, like delete at the beginning, delete at position 3, delete at the last, and also delete from the empty list. Comment down your thoughts below. Thanks for watching.